Hi, welcome to class. My name is Don LaFon, Professor Don, and this week in our A+ software class, we are covering Chapter 12, Internet Connectivity, Virtualization, and Cloud Computing. I'll also finish with a few slides explaining digital to binary to hexadecimal conversion. For those of you learning how to subnet, this will be a great beginning. All right, let me go ahead and share my screen. Move this. Start the presentation. Is it over here? All right, let's get going. Covers mentoring, that's the software, that's the soft skill, internet connectivity overview, modem overview, serial communication overview, traditional serial devices, a little bit about VoIP, voice over IP, mobile connectivity, virtualization, cloud overview, and web browsers. Now, those two of these last two topics, virtualization and cloud overview, we are really just talking about a very high level explanation of both of them. You could take an entire college course on just virtualization, and the same thing can be said about cloud computing. So this is just your first introduction, just as much as you need to know for that A+ certification. We'll also cover binary numbering systems, hexadecimal numbering system, and how to convert those to our normal, what you and I normally use, our decimal system. Qualities of a good technician. Every week we talk about these soft skills, and this week we're talking about mentoring. Now, no technician can attain his or her ultimate level without being mentored and monitored and mentoring someone else along his or her career. Now, the reason that's true is because you can't learn everything from a book or from experience. And what we do is we reach out to others that can help us along our journey, and then we repay the favor by helping others. I've also found that helping others is a way for us to learn faster. As an instructor teaching college classes, I have learned a lot more information about computing, is a lot deeper than I would have just by using computers. Take a few days when you first get to a company, when you first begin your job in the IT field, and find someone who appears to be professional, very knowledgeable, and somebody you would like to emulate. Now, it also suggests that prior to even starting a job, what you should do is reach out and create a LinkedIn account. Once you have the LinkedIn account, ask your teachers, the professors, the people who know you, to fill in what your capabilities are, what are your skill levels. We'll be happy to do that, especially if you're an excellent student. Then, once you have a LinkedIn account, I'd like to suggest that you start reaching out to people that are in your industry. What you want to do is you want to find people, whether at a job or before you even get to the job, that you can talk to and explain your goals. Ask if they'll mentor you. Find somebody online, especially somebody that works at a company that you'd like to work for, and then see who works there. See who's on LinkedIn. Don't reach out to them and say, hey, tell me everything you know. Get them talking about themselves. People love to talk about themselves. And find out, ask questions like, how did you get your job? Where did you find your desire? How did you know the job was right for you? What do you suggest that I put perhaps on my resume? What classes should I take in college? What college classes did you take? What college did you go to? What degree did you get? What experience? Is this your first job? What jobs did you have before this job that helped you prepare for this job? Those are the kind of questions that people love to talk about themselves, and you can get people starting to talk to you, and they'll like you because you're interested in them. It's a nature of being a human being. If somebody's interested in you, you start liking that person. It's just true. So once you reach out to that person, once you make a connection, once you start learning, follow up with them about what progress you're making. You'd be surprised how many people at our college actually get internships with the people that they find on LinkedIn early in their college career, because they reach out and they say, "Oh, you have any idea about an internship?" And he said, "Oh yeah, I know you, Don. We've been talking for a while. Let me see what I can do." And next thing you know, you get a job position for that internship. One of the requirements to get most of the degrees in the IT field. Once you have the job, consider mentoring others. You need to be the person that can lead others along. What you don't, knowledge is power, and you want to share that power with others. Holding all that power inside you just makes you look like a jerk. What you want to do is you want to share the information. When you share information and you bring others up, when you get promoted, because people will see what you're doing in the company and how you're helping other people, and they'll see you in a management position where you can be helping other people. Once they see that, they'll move you up. And then the people underneath that you've been helping, they'll trust you because you've made a relationship with them where you shared information. If you're always holding back information, hiding it, misering the information, thinking that you can't be replaced because you're the only one that has the information, guess what? You're the first person to go when somebody comes along that is willing to share and willing to train, willing to help others. So mentoring, very important, not only to be mentored, but also to be mentored, to be a mentor, but also to be mentored. All right. Internet connectivity overview. Great part of this presentation is many of you know one or more of these connectivity devices because you're all on the internet. So you got here someplace. So we're going to talk about internet connectivity. We're going to talk about connecting to the internet and how it can be done. Analog modems, ISDN, cable modems, DSL, all kind of older ones. I guess cable modem is still very current. Satellite is still in effect. Fiber, what I have at my house, fiber to the house is awesome. Wirelessly, power line, and cellular network. Now, these technologies have unique installation and configuration methods, but all share the capability to connect your computer to the internet and the outside world. And when you're working for a company, it's maybe your job to, when you're seeing one or more of these options, when people that you're working for or with, to get them connected if they've lost their connection. Dial-up overview. Well, let's talk about a modem. Modem stands for modulator demodulator. It connects a computer with the outside world through a phone line, the good old POT system, frequently called a dial-up network because modems use the traditional phone line to dial up or call another modem. Modems can be internal or external peripheral devices. Does anybody remember this sound? Let me stop and get that sound to play. Okay, I'm not sure why the sound didn't play the first time around, but it's playing now. I hope none of you still have a dial-up modem because they're pretty slow. I remember when I first started computers in the late 80s, early 90s, computing devices were connected by 2400 baud modems, and I could literally see the white text printing letter by letter on my screen. That's how slow 2400 bits per thousand bits per second is. 56K was really the last modem speed that we used in production. 5600. And then we had, we don't need to hear that twice. We also had 5600K modems, that was ultimately the last of the fastest modem speed. Modems transmitted, received, and received at different speeds. A faster modem meant less time on the phone line and less time for processor interactive. I got to change my screen here. Determine the fastest connection speed. In life, we do that. When you're talking to somebody and they're talking really slow, really fast, you kind of mimic that. And you're better off speaking at the slower rate. That way, instead of trying to get somebody to increase speed past where they really feel comfortable. So a modem, let's say you had let's just take the 24 baud modem and the 56K baud modem, and we connect the two. The fastest we're going to communicate is at 2400 baud. Modem speed settings should be set to the maximum throughput. Obviously, you wouldn't want to cut in half a really slow connection. And digital phone lines are quieter than analog components, have less noise on the line, and allow faster data transmissions. I'd like to hear if any of you out on the internet are watching this video and you have a slow connection, a dial-up connection, how are you able to watch this video? I would suspect that that speed modem wouldn't be able to push these lines. In the United States, where we still see these modems is inside of ATMs. Every now and then, when you try to get money out of a machine, ATM machine, you might hear in the background that sound I just played for you. And what it's doing is, it doesn't have to be a fast connection to sign in and determine how much money you have in your checking account. It just has to be able to do it. And you're willing to wait the 2 minutes it might take. So ultimately, a 5600K modem is an easy way to save money. Now, we also have serial communications. Serial device, such as a modem, transmits or receives information 1 bit at a time, and it's traditionally connected to a serial port. A USB to serial converter is used to attach an external serial device, such as a modem. I'll tell you where we see that. I've mentioned before that I teach Cisco. I teach Cisco routers and switches, and on the router and the switch, we have RJ45 ports known as COM ports. Those COM ports connect to a special Cisco rollover cable. That rollover cable ends in a serial connection like you see here. Now it's blue. It's always blue, and it connects to the blue port. This isn't blue, it's pink. But that COM port, that's how since most laptops don't have a serial port anymore, what we need to do is we need to get a converter that will connect to this side and turn port, which then you can plug into your laptop or whatever you're trying to access. Routers and switches inside of Cisco equipment have to be initially configured using a rollover. Actually, a switch doesn't really have to be initially configured. It can work right out of the box, but because you need to be able to perhaps manage it remotely, or perhaps you need to set up some security on that switch, then you're going to need one of these serial to USB adapters to be able to connect from the RJ45 port on the device to a laptop with a USB port. Asynchronous transmissions add extra bits to the data to track when each bit starts and ends. We call that encryption. Synchronous transmissions rely on an external clock to time the data reception and transmissions. Digital modems and ISDN. A digital modem connects a computer directly to a digital phone line rather than to an analog phone line. One type of digital phone line available from the phone company is an ISDN line. ISDN stands for Integrated Service Digital Network, ISDN. That line has 3 separate channels, 2 B channels and a D channel. Now each B channel handles data at 64K and combined will give you a speed of 128. The D channel is for network routing information and transmits at a lower 16K per bits per second. Now, I just want to point out, we're still talking about 128K, 128,000 bits per second, twice the 56K baud modem that I was talking about earlier. Really still a slow connection. I'd be interested if anybody's still using an ISDN connection out there. VoIP and quality of service. VoIP over voice over IP, VoIP uses a corporate data network and or internet for phone traffic rather than using the traditional public switched telephone network POTS. Now, PPS, public switch telephone networks, we call it POTS. I think we do. Anyways, voice over IP allows your company to avoid the charges your phone company might charge for long distance calls. So you can call anywhere in the world as long as it's going over IP, there's no charge. I'm old enough to remember long distance charges at 10 and 15 cents a minute from back in the 70s when I have to call family members, and that added up quickly. You talk for an hour at 10 cents a minute, we're talking about $6, and that's a lot of money back in the 70s. Today that would be maybe $20, 10 cents a minute. Now we don't have to worry about that. We just get online and we call, or heck, we can even get online and video conference all over the world using tools such as Skype, for example. I remember my first free video call to somebody in another country, a friend that we had met here in the States, and we call him in Venezuela, and it was amazing that I was talking to somebody with video for free. Now we have to use quality of service, QoS, to prioritize traffic. So important traffic like VoIP traffic, maybe you're doing a web conference, those are sure to get through. And other things like web surf data, you want to, that's going to hang in there and actually be given a bigger portion of the signal. Entertainment, restrict how many people can, or what people can watch during specific times. Maybe Netflix, for example, or YouTube traffic, cutting back on that. Web surfing, if a website doesn't load because that was more important, then the website will just be requested. How many times have you hit refresh on a website before, or hit enter again just to reload it? So you understand that if you have video or voice, it's much more important not to lose the words or the site, the pictures, than it is for a little bit of web surfing traffic that you can pick up later. Cable modems connect a computer to a cable TV network. Can be internal or external devices, but normally external. If a cable modem is external, two methods are commonly used to connect it to a PC. Every device on the internet has a NIC. Now that NIC may be built into the motherboard using it, or you may have to add an adapter to the computer that adds a NIC. A cable attaches between the NIC and the cable modem. NIC stands for Network Interface Card. Every single device in the internet needs a NIC, a unique MAC address that uniquely identifies that device. Every light bulb in my house, my dryer, my stove, my coffee pot, everything has a NIC, and I can communicate with my TV, I can communicate with my phone, turn on lights and turn off the TV and turn up the volume and all that stuff, all done through the internet because my device has an address. The address is the NIC, the network interface card. And the NIC is burned in a MAC address. The MAC address is like your 123 Main Street. That would be the address. Cable modem also might connect to the USB port on the computer, but the computer still has a NIC assigned to it so that it can be uniquely identified out on the internet. xDSL modems. The X in the term xDSL refers to the various types of digital subscriber line DSL. The most common one is asymmetric DSL, ADSL. Now, ADSL uses faster download speeds than upload. Asymmetrical means different, not the same. And that's fine for most home users because we don't upload as much as we download. DSL uses traditional phone lines, but are able to send and transmit not only voice, but also internet data like video. I had a DSL line in my home, and I was connected to my home for many years, and I was thrilled that it had 4 megabits per second, 4 meg compared to my 56K modem. I forget if I had a cable connection or how fast that was, but the DSL at the time was much faster than the dial-up that I had previously. Now, some people must use satellite modems for their broadband connection. Satellite relays communication back to the receivers on Earth. Satellite connectivity requires a satellite dish of some sort and a satellite modem at the minimum. It also requires an analog modem and other equipment depending on the satellite provider. Now I'm going to zoom in on this. You can see that the downlink, how much you download from the provider, is much higher. This is data from a speed test intelligence Q4 of 2021, and you can see the download for the fastest connection was 104 megabits down, only 12 up, and then the latency was pretty low at 40. Latency is the delay. When you think about latency, when you're driving to work, in the morning or when you're coming home at night, that latency is the slowness that you're experiencing in the drive, the delay between devices. And you can see some other speeds. I didn't really show it to you to compare the three. I just wanted to indicate that these speeds are, in this case, SpaceX Starlink, the newest that's coming on the market right now, you may have heard about it, is at least 5 times faster than HughesNet and others, and it has a much faster upload speed than others as well. Still really slow compared to fiber to the house. I get a fiber connection that comes all the way into my house, and then I have RJ45 from the fiber box to the computer, and I get about 800 megabits per second. It's not only faster than satellite, but it's also less expensive. Satellite modems connect your house through a satellite link to a satellite. It's relayed to other satellites and then ultimately downloaded to your ISP, and then it's reversed to go back out to you. Mobile connectivity using wireless connections such as a USB port, Bluetooth wireless connectivity, or cellular network. Wireless connections can provide wireless internet connectivity to others in the immediate vicinity. The term wireless hotspot is also used to refer to an area of wireless connectivity. Sometimes, we're finding it's more sometimes free, such as in a park, coffee shop, or museum. Companies jumped on the bandwagon with providing free hotspots, and then they realized people would pay for them. At least here in the United States, we're finding that more and more hotspots, you have to be part of a program or a provider's network to be able to access a hotspot for free. Mobile connectivity, wireless broadband that has download speeds of up to 45 megabits per second. There it's referred to wireless, and it covers, it's passed through the cellular wireless area network, wide area network. Cell phone companies and internet providers offer USB modems, modem data cards, integrated laptop connectivity to have the ability to receive, create, and communicate internet information within a coverage area through the cell towers. Now, I want to mention that this number, 45 megabits per second, it's based on the current A+ exam. Obviously, with the release of 5G, which is much faster, at least 10 times faster than that, we have faster download speeds now than we had just even a few years ago when these slides were created for the A+ certification that you're studying for. If you're taking an exam and they offer you a speed option and they offer you 56K, um, uh, 4 megabits per second, 20 megabits, and 45 megabits, you definitely want to go with the 45. Well, if you put down that it's a 400 megabit connection, it may be wrong if that's one of the options. Even though today that's common, it wasn't common when this exam was created, when these books were written and the PowerPoints were created for them. That's everything with connectivity. Now we're going to talk about a little bit about virtualization. As I mentioned earlier, virtualization, it could encompass an entire course, and in this slide presentation, it's just one slide. It's everything you need to know for the A+ certification. After the A+ certification, if you decide to focus on virtualization, which can absolutely help land you a job or progress in your job, then there's plenty of information on the internet to learn more about virtualization. And as I mentioned earlier, the college I work for actually has an entire 16-week semester course on virtualization. But they go into in-depth how to do it. Now, all we're going to talk about is what is it? Now, a virtual machine is not exactly real. Each virtual machine is an instance of software running on the base computer. Now, there can be two options. It can be an internal network, the computer you're currently on, which allows a particular VM access to other virtual machines that connect to the same network. Or it can be an external network, allowing a particular virtual machine access to a different external network, such as the internet from within a VM. Now, let me tell you about it, and I'll give you an example of internal and external. Let's zoom in. I'll zoom in on this picture first. Takes the actual hardware and hardware on your computer when we're talking about processing power, RAM, hard drive space, and maybe even something like a CD-ROM, and it allows instances of another program. Now, what we do is, let's say on my computer I run Windows 11, and the hypervisor is built into Windows 11. So I can open a virtualization. Now, you might have to modify the BIOS, the UEFI BIOS, to enable the hypervisor. But once you do and everything's set up properly, just Google whatever operating system you have and enable hypervisor. And once you do that, then what you do is you set up safe zones. I like to consider them boxes. And in the box, they call it a virtual machine. In the box, you give it so much RAM, so much hard drive space, so much processing power, and you give it access to a USB or a DVD or whatever. Now, in that box, then you can load an operating system. So in this case, maybe I'm running Windows 10 down here, and I'm going to install a 64-bit Windows 7 for some reason. I also want to install maybe training. I want to teach Windows 7 to somebody because they're still learning Windows 7, or they have to take the older exam or something. Fortunately for you, Windows 7 and the not only Windows 7 but Vista no longer taught. When I got my A+ certification, I had to learn Windows 7, Windows 8, and Vista. That wasn't. You guys have it easy with 7, 8, 8.1, and 10. I'm kind of hoping. I'm kind of hoping 7 gets dropped when they come out with the next iteration of this software, because then 8, 8.1, 10, and 11 would be much easier to teach, and everybody's much more familiar than the old Windows 7 software. But let's say, here's another example. You're loading Windows 7 on your computer so that you can maybe you liked Windows 7. You want to keep using Windows 7. Maybe you want to mess around with it. So you have a safe box that you can go in and you can play with it. You can do anything to the software. It will not affect the whole computer. The main hardware is protected from the virtual machine that you create. Now, here's another example. Let's say you miss Windows XP, or maybe you have a game that only runs on Windows XP, and you want to play that game, but Windows 10 laughs at you when you want to try playing it. Well, you can laugh back because you can open up the virtual machine, open up the hypervisor, create a virtual machine, load Windows XP on it, and play that game to your heart's content. You're actually literally in Windows XP. It feels like it. Matter of fact, it's installed with the XP CD-ROM or USB or whatever you got to load the operating system. You actually have to have a Windows 7, Windows XP, who knows, Windows 3.11. I haven't seen that in more than 20 years, but maybe you find a copy of it and you want to play around with it. Try it in a virtual machine. And let me know if it works down below in the comment section. I'd love to hear if anybody's running a Windows 3.11 machine inside of a virtual machine, or maybe why that wouldn't work. That would be helpful as well. All right. So I can zoom in again down below. So there's some terms that you need to know. I gave you the internal example of why you would want this on your computer. An external example, I like to use the example of our college buys a certain number of Adobe Acrobat DC licenses. I believe it's in the range of 120 licenses. Now, what they do with those licenses is they don't just hand it out to 120 people, because then they'd be out of licenses and there wouldn't be any for the 121st student or worker, teacher, admin, executive, whatever, to be able to use that software. So what they do is they've created a virtual machine that you access in the internet. All you need is the IP address to the virtual machine, the website. It's not an IP, it's actually a website. You go to that website and you sign in. You have to have a sign-in and password. And when you get on, you are actually on something that looks like a desktop. I'll bring it up later with the virtual cloud, but it looks like a desktop, a Windows 7, 8, 11, 10, whatever it is that they've decided to use for the operating system. Then they load the Adobe Acrobat DC on top of that operating system. You sign into it remotely. There's 120 seats. The first 120 at any point in time that get into the virtual machine can use that software just as if it was loaded on their own computer. It's an external network, and you're using a VPN, another computer. Now, the 121st person, when they try to sign in, they'll get an error message that indicates that the network is full and that they have to come back later or wait. And you literally have to do that. You have to wait for somebody to finish their homework or finish a project that they're working on before you can get in and use that software. This is real. This is our school actually uses it, and I'm 99% sure they use that software. And there's many other softwares that they don't want to buy 1,000 licenses of because they're so expensive and they're so rarely used. That they'd rather put them on a virtual machine. Now, Adobe doesn't care because Adobe sold 120 licenses to the college I work for, and 120 students are using, or workers are using those licenses, so we are clean. It's okay. Now, if we just put 120 licenses and we duplicate it and we put it on every computer in the college and anybody could access it and we didn't pay attention to how many were on it at any one time, and maybe there's 300 people using the VM at one time, guess what? We would be, if they found out, we would be sued. Your company would be sued, and you would pay much more in penalties and fees than you would if for the actual software itself. So this is a solution that works, and we've implemented it at the college I currently work with. Now, Here are some of the terms that you need to know. Host machine, it's the real computer that holds multiple operating systems loaded on the equipment. Now, you've got to realize that in the virtual machine, when you give a virtual machine 2 gigabytes of RAM out of your 8 gigabytes of RAM, now you only have 6 gigabits left for the computer. So you have to be aware that as you're allocating resources, you're allocating real hard drive space, real RAM that is going to be used solely for that operating system. The virtual machine, also called a VM, is a separate operating system from the host computer that is specially chosen hardware components. You've decided it when you built the virtual machine. The hypervisor, also called a virtual machine monitor or virtual machine manager, it's the software that can create a virtual machine and allocate resources to the virtual machine. And a snapshot or checkpoint is a copy or backup of the virtual machine at a specific time, which can then revert the VM to that point in time when the person restores that point. When I went through this course, we used virtual machines to load multiple operating systems on our classroom computers. And we made snapshots at the end of every class, naming them our own snapshot, sort of like a, what do you call, restore point, sort of like a restore point in Windows or Apple has something like it, the Wayback Machine or something like that. I'm forgetting the term for Apples. But anyways, you basically take a snapshot in history so that later when I came back into class on, let's say Monday, Wednesday, I come back on Wednesday, I can just open up that restore point and pick up right where I was before. Now you have to save the point. If you don't take the snapshot or checkpoint, once you close the machine and then you sign back into the machine, it's completely wiped and you're back to scratch. So that's why when you have multiple people using a virtual machine on an exterior on a what do we call it, external network, multiple people can use the same virtual machine, because when one person signs out, it wipes it and goes back to where it was before, and then the next person comes in and they don't have all of the work from the previous person. By the way, if you have 12, we get 120 instances of the software. Each person sees their own instance of the software. They don't see other people in the network. Now let's talk a little bit about cloud computing. Now, cloud computing, again, you can focus your entire career on cloud computing because that's where it's going. It's moving into networks that are not located locally. And you can earn a living probably for the rest of your life, a good living, just knowing how to set up cloud networks. There's 3 major varieties. There's public cloud, hybrid cloud, and private cloud. Now, private cloud is the easiest one to explain. You create it. You create that space. My example of the virtual desktop where it has that operating system, that's housed in my college, but it's on a server that students can access remotely and admin can access remotely. That would be a private cloud. We own the equipment, we own the server. The only thing put out on the internet is the resources that students or admin or whatever people can sign into. You have to have a sign-in and password to get to that, but it's our equipment. Then there's a public cloud. A public cloud, let me zoom in a little bit. A public cloud, you've heard of these service providers before: Amazon Web Services, Google Cloud Platform, and Microsoft Azure. These are companies that are providing different layers of network capability out on the internet. And then the hybrid is a little bit of both, the best of both worlds. We'll get into that in a couple minutes. Now, a private cloud is part of a company's network infrastructure located outside of the business in a remote location. But the company is still responsible for managing the software and or hardware. They have to do the updates. They have to fix the equipment if it breaks. They're responsible. A public cloud is an environment operated by a cloud provider. like I mentioned a moment ago. A hybrid is some combination of the two. With the community cloud, a number of organizations have access to the IT resources that are in the community cloud. That's a new term that has resulted. So no cloud, that's where everything is within the building. Private cloud, you have everything in the building, but you also have some resources that are outside of the company itself, but you control it completely. Hybrid, what? I don't see the, okay, a public cloud, everything is located outside and managed. Even the operating system, all of the updates, all the patches, everything is taken care of. Even the equipment can be out here. And then hybrid is part of the both. Part of both. I'll come back to it. Now, when we're talking about cloud computers, people love to say, and I said it for a long time, I said someone else's network. When you talk about cloud computing, cloud is just a term, a pretty term, a term to help people be comfortable with you putting their information on somebody else's computer. iPhone users, Google users, we take pictures on our phone. It's uploaded to the cloud. Everybody feels comfortable with that. But if you said uploaded to Google's network, or if you said Apple's network, then you would be a lot of people would not like the idea of their pictures being on somebody else's network. But that's ultimately what we're talking about. Now, when we're talking about somebody else's network, like my example of the operating system with Adobe Acrobat DC on it. It could be applications. It could be hardware. It could be data storage. All of that could be out on the internet. It could actually be the actual hardware could be out in the cloud. It's just a process of determining what layer what we currently have, and I'll get there in a minute. We'll talk more about it in just a minute. Cloud technologies. Most popular cloud services include offsite email applications, cloud file servers, file storage services. You might do that yourself. If you don't back up your hard drive to an external RAID cabinet sitting on your counter, and instead you're paying for Google or which I do pay for Google to back up all my pictures. They're all out on somebody else's web, somebody else's internet network. The cloud. If you might be paying ASUS for cloud storage, right? They sell it to you for, I don't know, $12 a year, and you can load a terabyte of data out on the internet, right? It's somebody else's storage services. Virtual applications, streaming, cloud-based applications. You do that, most likely your Office 365, unless you've installed it on your personal computer at home, you probably log into Word, Excel, PowerPoint on the internet, and you use a virtual application. Office 365 can be downloaded, but many people just use it occasionally, and they're happy with using the application. That's actually software as a service in the next block here, SaaS, software as a service. And Microsoft came up with a great idea. Instead of selling Microsoft Office for $125 for the 4 main programs every 3 years, changing it out, they realized that at a certain point, people with, say, Office 2013, that version of the software was all they need. I actually go to I tutor a woman, and she still has Office 2013 on her computer. It's very different than what I use at school and what I teach with, but she can write a letter, she can modify a picture a little bit, and she can keep track of a small inventory using Word. She can make a little PowerPoint if she wanted to. I don't think she ever has, but ultimately she has that software and she's been happy with it. Now 2013 is almost 10 years ago, and she's happy with it. She's probably never going to pay more. Now, Office 365, a SaaS, software as a service, you sign up and you pay $10 a month. or not, whatever it is, $120 a year for that service. Microsoft they always give you the newest version, updates automatically. We love that. We love having the newest software all automatically loaded on our computers, but we pay for that because no longer can you just buy $100 software and then keep it for 10 years. You have to continuously pay that $100 a year for the service of that virtual application that's out on the internet. Or Microsoft lets you download it. Cloud-based network controllers, you can actually control networks. You can actually build out your network. So I like to talk about a brand new company that just starts up, and let's say they're an IT company and they have $100,000 worth of infrastructure that they have to build out to be able to do whatever the job is that they're doing. Now, they could just go out and buy that equipment, but I'm sure many of you have heard that 80% of companies don't survive 3 years. 80% of startups don't make it 3 years. So if a company comes online and pays $100,000, borrows the money, buys the equipment, uses it for 3 years, and then goes out of business, or less than 3 years, goes out of business, and then they have to try to sell that equipment, and they're going to sell it at a loss, and ultimately that's going to be a big hit on their profits, especially in the first year. Now you can write it off, I know, but ultimately the idea is it's coming out of pocket. Even if you're borrowing the money, it's coming out of pocket, and then you have to update it, fix it, and everything. If you use IaaS, infrastructure as a service, with cloud-based network controllers, for example, you can actually have somebody else have the equipment. All you have is a connection to the network that they are hosting. It feels like your network. It looks like your network. Heck, when I'm in the classroom and I boot up my computer, I don't know if it's connecting to the NOC, the Network Operating Center, or if it's connecting to some, Microsoft or Amazon services. I don't know. You wouldn't know unless you are the actual IT guy. So clouds we're running like Microsoft Office to the entire infrastructure running out on the internet. Now, in that case, let's say that same company, maybe they pay $1,000 a month for the software. Right now, in the hardware, access to the hardware instead of $100,000. Right now, you're thinking, wow, $1,000 a month, but they don't have the $100,000 upfront payment, the interest on that money. Instead they have $1,000 a month. If they find over time that they want to invest in their own equipment because their company is going strong, they can start taking some of that back in-house and bringing it private. Otherwise, if they go out of business, then now they don't lose anything for that $100,000. Let's say they lasted 3 years, went out of business. They spent a total of $32,000. They've lost $32,000 instead of $100,000, or whatever the difference between selling the products, the hardware, and buying, and what you paid for it. Desktop as a service, DaaS. This is my example of Adobe Acrobat DC loaded on the college's computer. And platform, this is it's in between. It's in between everything and just software. It's some of the hardware is out there. I actually have a link here that I'm going to open, and that link is where I got some of my information. As I said earlier, you can spend a lot of time learning about cloud, and you need to learn the difference between private, public, and hybrid. And here is a great website that talks about the battle of the clouds. Now this is actually a little out of date. A lot has happened since 2019, but I liked this article by Dipti Parmar. I apologize if I'm mispronouncing your name. She goes into talking of the IT ecosystem because there's an opportunity to use basically somebody else's equipment. And it goes into how the market and how it's growing. Then they talk about the many dimensions. And I love this picture here. Now, I know it's a little blurry, but I'm just going to go through it. So let's say you're hosting everything. This is this is on, this is private. This is your equipment hosted someplace. And that's everything. You got the apps and the data and the the middleware and the operating systems and the virtualization and the servers and storage and network. Everything is in-house. But you could do infrastructure as a service. That's where you rent some of the equipment. Maybe you keep the apps and the data and the runtime environment, middleware, and the operating systems, but they have virtualization, servers, storage, and networking. Or platform as a service where you just have the apps and the data. You don't trust anybody else with their data, so they have everything but the apps and the data, right? And then finally, we have software as a service. This is where everything is theirs. They're handling everything. Now, what the advantages and disadvantages is, well, you control more on this end. And as you move along, where you ultimately give everything away on the other end, your control diminishes. And that could be good in some cases because you ultimately are now not in charge of updating all the software now. And then she goes on to talk about the pros of public cloud and cons and private cloud and the hybrid. So I encourage you to read her article, pause the screen, the link itself. Oh, I don't have the link for you. That's a shame, but I can put it in this video. I like it, but private versus public versus hybrid, and her name is Dipti Alamar, Dipti Parmar, and you probably don't need the date for the search article, but anyways. Okay, let me close out of this. I like that article. I thought I'd share that with you. So let's talk a little bit about advantages and disadvantages. So the advantages of the cloud: reduce cost, increase flexibility, increased efficiency, constantly applied software patches and upgrades, corporate focus, meaning that you can focus on your company, let somebody else focus on the IT. 24/7 access. You don't have to worry about your equipment going down. They guarantee. Usually it's 5 nines, 99.999% of the time they guarantee your equipment will be up. Rapid elasticity. I love an IBM commercial where it talks about a product just hitting the market and everybody's excited. They're all sitting around their computer when they get the first sale, and then the 5th sale, and then the 20th sale, and they're all cheering, and then the 200th sale, and the 2000th, and the 20,000 sale, and they're like, oh my God, what are we going to do? Because they don't have the infrastructure for that. Well, elasticity means when your company needs more, you can expand, pay a little bit more, get more services, whatever it is that you're paying for. And then when it slows down, you can pay less, and you can get less, maybe less storage space, fewer servers, less bandwidth, etc. Resource pooling, that means you're able to resource, say, storage, resource any kind of resource, but memory, storage locations you can pool, share, instead of having every computer in my classroom having a 2 terabyte hard drive. You can have one 20 terabyte hard drive out on the net and out in somebody else's computer, and everybody can store to that one pooled location. That's what they mean by that. Measured service and metered service based on, they're talking about how you're charged, whether by it's how much use or time. Disadvantages: well, there's a risk of data confidentiality. There's always a risk that the user data can be accessed by other people. It's not in-house. Somebody else has your equipment. So there's always that possibility. It depends on an internet connection. When my company, the college I work for, when it loses an internet connection, guess what? We lose everything. Everything is connected through the internet. We don't have access to any of the data. We sit and twiddle our thumbs. We open a book and read. We play on our phones. It doesn't happen as much as it used to because now they have battery backups to ensure that the equipment doesn't go down. The level of security, you do control it, but you're really controlling somebody else's equipment. Let's say you have a locked gate at your company. You can have somebody check on it on a regular basis. If there's a locked gate on your equipment that's being hosted by somebody else, you're relying on somebody else looking at that gate or accessing the security passwords and whatnot. Compliance. Disadvantages with compliance is it may be challenging to comply with legal requirements if somebody else is holding your equipment. Vulnerability, the event of an attack. Data mobility might not be so easy to move it from one place to another if it's on somebody else's network. You don't just switch um, uh, service providers on a regular basis because it can be challenging to move everything from one place to another. Technical problems, you rely on somebody else to troubleshoot. In many cases, the problems that you're having, and low connection speed, again, back to the internet connection requirement. Now, for some reason, they mentioned web browsers here. I'm not exactly sure why, but web browsers is a graphic interface between a user and the internet. Most browsers are customizable, and many are set to many settings relate to security. A browser can be hijacked, either replaced where a website is the homepage is replaced with another one, or you're just directed to a different page that's being used. So you have to be aware of being scammed on the internet, and you have to set your security features options to be able to protect you. I use a browser that when I'm in a known secure HTTPS connection, the website, my URL turns green. And when I'm in a dangerous place, it actually turns red. I haven't seen red in a long time because normally the browser keeps me away from there. It gives me a warning and I just don't continue. But I've seen red because I was stubborn and thought for sure I knew where I was going. But it's white any other time, but green when when I'm at my bank. All right, that's it for the normal presentation. So if you're just working on your A+ certification, you can stop watching this presentation now. But if you're at the college that I'm teaching this course for, you also need to know something about numbering systems. So here's a little bit about supplemental information. We're going to talk about binary numbering system first. The reason why you need to know the binary numbering system is because that's what computers use. The binary numbering system consists of ones and zeros. They're called bits. The decimal operating system consists of the digits 0 through 9. We use the decimal system numbering system worldwide. If you're in a place that doesn't use the decimal numbering system, let me know in the comments down below. I'd be interested to know where you are. But anyway, 0 to 9, then you carry to 10, right? Well, 1 and 0, you go 0, 1, and then you carry to the next spot over. So 0, 1, 1, 0, then you carry to 1, 0, 0. I'm not going to explain it right now. I have slides to show you. The decimal, let's see, host servers and network equipment use binary addressing to identify each other. They see themselves as 32 bits, ones and zeros. This is how they see themselves. So the network 11000000101010, you get the idea, right? All ones and zeros, 32 of them, followed by 32 more ones and zeros with 24 of them set to 1. This is the subnet, and we'll learn about subnetting in a different slide. All you got to know is this 32 bits in the address, in the IPv4 address, and then 32 bits in the subnet. Now, this is the IP address of the PC1. So 110000, you'll see it's in the same network. These match up. But when you get here at the end, instead of all zeros for the network, you have 1010. So this is, what is that? 4, 5, 6. Is that 6? Let's see. I'm struggling now for 0, 1, 2, 3, 4, 5, 6, 7. That doesn't sound right. I'm sorry. 1, 2, 4, 6, 7, 8. So, erase everything I just said. All right. This is the 0 spot. This is the 2 spot. So this is 0, 2, 4, 8. Right? And then 10. So this is 10. Okay, I know how to count in binary. I'm just rushing. I apologize for that. Anyway, so this is the IP address for this PC. This is the IP address for this PC. I can do that one fast. Look, it's 1. That means and usually the gateway, the router's IP address that connects to a network usually is the first address or the last address, the last usable address. It's never, in this case, the last address would be 255. 255 is the broadcast address in a /24 network. So it would never be 255. It would usually be either 1 or 254 in a /24 network. Often it's just 1. Here you can see we have a different network. This is the 10 network. This is the 11 network. It has the same subnet type. Here we have G00 has 1, but it's in the 11 network. And this PC has the 10, the same address I gave you earlier, but it's in the 11 network. You know, I'm glad we don't have to just quickly add binary. In this case, you can see how, and here's a whole other address, right? So a whole additional address. So here, I'd much rather use dotted decimal. Dotted decimal allows us to take binary numbers, turn them into decimal numbers, and then we memorize the decimal address. Here, yes, I got it right. It is the 10 network. So 192.168.10.10, that's IP address for this device, the 10 network, IP10. This is 10 network, IP1. This is the 10 network itself, right? First address or some random number in that range, and the switch connects the PC to a router. Switch doesn't have an IP address. Switches don't have IP address unless you want to assign an IP address to a switch to be able to remotely manage the IP address using Telnet or SSH. Then you give it an IP address, but it's set to a virtual address. It's not on any one port. So no IP address here or here. It might have one so that you can SSH into it and remotely access the switch and make modifications, but it doesn't have a port address. Anyway, so this is how we see it, right? We see it this way, and I'd much rather type that in when I'm configuring equipment than typing in all ones and zeros, right? Yeah. For ease of use, the dotted notation is converted to dotted decimal. We don't want dotted ones and zeros. We want dotted decimal, something we understand. I have a video here that talks about how to convert binary to decimal numbering system. First of all, it just talks about basic positional notation so that you understand power of 10. You should be probably using in the United States, you're using the power of 10 with our dollars. Canada, same thing, right? Most of the world, most of the world uses decimal, but not dollars. Anyways, base 10 numbering. Then we convert the understanding of base 10 to base 2 so you can understand it. And then we convert an IP address in binary to a decimal number.
It's binary to decimal conversion. But before I do this, I want to take a look at positional notation or place values. I have the number 2,168 here. If we look at the place values of the number 2,168, we can see that the place values have the ones place, the tens place, the hundreds place, the thousands place, 10,000, 100,000, and million. These are the place values of the base 10 decimal number system. You can see that we have the number 2 in the 1,000s place, so we have two 1,000s. We have a 1 in the hundreds place for 100. We have 6 in the tens place for 60. And we have 8 in the ones place for 8. So effectively, we have 2 1000s, 1 100, 6 tens for 60, and 8 ones for 8. Now, when we're talking about the place values in the decimal number system, we're talking about the powers of 10. You can see that the ones place is the 10 to the 0, the tens place 10 to the 1, the hundreds place 10 to the 2, or 10 times 10, which is 100. The thousands place is the 10 to the 3, or 10 times 10 times 10, and so on and so forth. So you can see that the place values are based on powers of 10. If we look at the number 2168 then in long form, we can see that effectively we have 2 1000s, 1 100, 6 tens, and 8 ones, and 2000 plus 100 plus 60 plus 8 totals 2168. This is the type of counting and addition that we learn as children. The decimal system is base 10. It's based on the fact that you have powers of 10, but more importantly, you have 10 characters or 10 numerals in this counting system from 0 all the way up to 9. So that means that in each place value, you can have anywhere from the number 0 up to the number 9. In other words, if I had the number 9168, I'd simply replace the 2 here with a 9, and now I have 9 1000s totaling 9000 in the 1000s place. So in any one of these place values, you can have the number 0 all the way up to 9. This is the base 10 decimal number system. If we consider binary and look at it in the same light as decimal, 2 characters or 2 numbers, 0, we can only have zeros or ones. The place values go from 1, which is 2 to the 0, to 2, 2 to the 1, 4, 2 to the 2, 8, 2 to the 3, or 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. That's 2 to the 4th power, place value of 16. The 32's place, the 64's place, and the 128's place. Notice that I extended the table to 8 place values. That's because 8 bits is an important grouping of numbers. 8 bits makes a byte in computer processing. So now I have the place values for essentially 8 bits. If I want to write the number 168 in binary, I just have to find the corresponding place values and plug in either a 1 or a 0. So I'll go to the 128's place and ask myself, do I need 128 to reach 168? Yes, I do. So I'll put a 1 there. Now, do I need a 64? I already have a 128. If I add 64, I would get 192 because 128 plus 64 is 192. So the answer is no, so I put a 0. I still have 128 now. Now, do I need a 32? 128 plus 32 is 160. So yes, I could use a 1 here. Now I have 160. Do I need a 16? No, that would make 176, which would go over my target number of 168. I'll put a 0 here. What about an 8? If I add an 8, I'll hit the number perfectly. 128 plus 32 plus 8 is 168. I'll follow this up with zeros in the 4's place, the 2's place, and the 1's place. And 168 in binary equals 101,01000. I now have 128, I have 132, and I have 8. And 128 plus 32 plus 8 equals 168. If we go to the next slide, you can see now that I'm now charged with converting the number 01101101 to decimal. If I want to go the opposite way and convert this binary number to decimal, all I need to do is plug it into the place values. I'll put it in here, 0, 1, 1, 0, 1, 1, 0, 1, and then add it up. I have a 64 and I have a 32. 64 plus 32 is 96. Plus I have an 8, that makes 104. Plus 4 makes 108. Plus 1 makes 109. This number converted to decimal is the number 109. Now let's look at a full IP address in binary. I'll go to my next slide. And you can see in this next slide, I now have a 32-bit IP address, 4 octets, or 32 bits total. If I want to convert this binary IP address to decimal, all I need to do is count up each individual octet. Let's start with the first one right here. We can see that 1, 1, 0, 0, 0, 0, 0, 0. 128 plus 64 is 192. Now, the next octet has 10101. Let's do that one. 0, 1, 0, 1, and then all zeros. If we count up the numbers, 128 plus 32 is 160, plus 8 is 168. The next octet is all zeros with a 1 in the last place in the ones place. This is easy. This is the number 1. All zeros and a 1 in the ones place makes the number 1. And then finally, we have a number here. I'll plug it in here to my table. And I have the number 011000101. We can see that 64 plus 32, we've already said, is 96. Plus 4 is 100. Plus 1 is 101. So the conversion of this binary IP address to decimal is 192.168.1.101.
Now, if you guys take my Cisco class, or if you're interested in continuing to learn about Cisco, you'll find that that same video is in my Cisco class. I had to find some basis for information here, and they did such a nice job explaining converting binary to decimal and what the binary and decimal numbering systems are. I thought I would share that with you. All right. And this just shows you what she just did. He just did. So again, base 10, we're used to this, right? So if you have, let's say, if you have so many $100 bills in, actually not fives, 100 tens and ones, then you can add up to a value. And that's all they're doing there. Same thing with binary. So many location, which is, and this is the first thing you write down. So you write down 8 spots, and you double it from the right. 1, 2, 4. This is the check. 2 squared. Everybody knows 2 squared is 4. Make sure you're in the right place. 8, 16, 32, 64, 128. And then you just fill in whatever the number is that you have. In this case, 128 and 64, they add up to 192 easy. And then they just show you here how you just keep doing it for all of the dotted decimal notation. Logically, what we're doing is we're taking the number, say 168, for example, and we're saying, are there any ones in it? And if there are, you put a 1 in, and then you subtract 128 from the number. Let's say 168. And then you say, all right, are there 168 minus 128 leaves you 40. Put a 0 there. Are there any? Is 40 greater than 32? Yeah. So you put a 32, you subtract 32 from 40, it gives you 8, and that fits perfectly here with 0 through the rest. It's really that easy to do. Now, again, just to why we just did what we just did, routers and computers only understand binary. We want to work in decimal. So it's important for you to gain a thorough understanding of these two numbering systems and how to move between the two. Now, if you thought binary was interesting, wait till you see hexadecimal, right? Hexadecimal numbering system. We have 0 through 9, and then we add A through F to get 16 spots. Hex is a 16-bit operating system. Base 16 uses 0 through 9 in the letters A through F. It's easier to express a value as a single hexadecimal digit than as 4 binary bits. Hexadecimal is used to represent IPv6 which have 128 bits. If you thought 32 bits was a lot using IPv4, a lot of ones and zeros, try writing and keeping track of 128 ones and zeros. This is what it looks like ultimately. Every IPv6 is broken, usually divided by colons, and it is 8 positions long. Each set of these 8 positions each spot can go from 0 to F. So this could be all zeros, all Fs, so 0 F, F, E, or it could be anything between 0 and FFFF. And that's for each set of these. Now, one group, see the 4 bits there, each one of those bits is worth 4 binary bits. 4 hexadecimal digits equals 16. 1 is equal to 4. And the way that is explained best is just to go ahead and allow you to watch this video. The video will cover the characteristics of the hexadecimal system and converting hexadecimal to decimal and then back from decimal back to hexadecimal. Let's watch the video.
Hexadecimal, or hex for short, is a base 16 number system. It uses 16 symbols, the numbers 0 to 9, as well as the letters A to F. It is based on powers of 16. If we follow the same procedure used for converting binary to decimal, we can write out the place values or positional notation for the hexadecimal number system as well. Here we can see the first 4 place values based on powers of 16. This is 16 to the power of 0 or 1. Any number to the power of 0 is 1. This is 16 to the power of 1 or 16. This is 16 to the power of 2 or 16 times 16, which equals 256. And this is 16 to the power of 3 or 16 times 16 times 16, which equals 4096. Let's look at the decimal and binary equivalents of each hex symbol. These are the decimal equivalents. Note that the hex symbol A is equal to decimal 10, hex B is equal to decimal 11, and so on until we get to hex F, which is equal to decimal 15. Here are the binary equivalents. Note that each hex symbol can be used to represent a 4-bit binary number. Given that 8 bits is a common binary grouping, we can represent an 8-bit binary number using just 2 hex symbols. In this first example, let's look at converting hex 2A to decimal. First, I'll write out the positional notation for the first 2 powers of 16, then insert the hex symbols below the corresponding place values, 2 under 16 and A under 1. Then I'll multiply each hex symbol by the place value that it's under and add the results together. So we get 2 times 16 plus A times 1. That gives us 2 times 16 plus 10, which is the decimal equivalent of A in hex, times 1, which gives us 32 plus 10, or 42 in decimal. Multiplying or dividing by 16 isn't always easy when doing hex to decimal conversions. Usually it's easier to convert the hexadecimal or decimal value to binary first, then convert the binary number to decimal or hexadecimal. Let's convert decimal 197 to hex. First, I'll begin by converting 197 to an 8-bit binary number. Here I've drawn out the system. We need to find out what combination of these place values adds up to 197. I'll begin by writing 197 on the left side, and starting at the left, if the place value is equal to or less than this number, I'll put a 1 under it and subtract it, and if it's greater, I'll put a 0 under it and move to the next place value. Since I can subtract 128 from 197, I'll put a 1 under it and subtract it, and that gives me 69. I can subtract 64 from 69, so I'll place a 1 under that and subtract it. That gives me 5. 32 is too big, so I'll place a 0 under that. 16 is also too big, so that gets a 0. 8 is also too big. But when I get to 4, I can subtract that, so I put a 1 there, and I subtract it here. 2 is too much, so a 0 goes there, and 1 is just right, so I subtract it, and it results in a 0. Therefore, decimal 197 equals binary 110000101. Next, I'll convert the 8-bit binary number to decimal by first splitting it into two 4-bit binary numbers, and then I'll rewrite the first 4 binary place values above each half. So here I have 1, 2, 4, 8, and then repeated on the left, 1, 2, 4, 8. Then I'll convert each half to decimal and then each decimal to its equivalent hex value. On the left side, we get 8 plus 4, which equals 12. And on the right side, we get 4 plus 1, which equals 5. If we convert those to hex, 12 decimal is the equivalent of C in hex, and 5 decimal is the equivalent of 5 in hex. Therefore, 197 in decimal is C5 in hex, or it can also be written with a 0x preceding it to indicate that what follows is written in hexadecimal. Lastly, let's look at converting from hex to decimal, but this time we'll convert to binary first instead of going straight to decimal like I did in the first example. I'll convert the hex 9F to decimal. First, convert each hex symbol to its 4-bit binary equivalent. I have hex 9, which is the same as decimal 9, and that gives me 1001. And then I have hex F, which is equivalent to decimal 15, and that gives me 1111 in binary. Next, I'll combine them into one 8-bit binary number. So here I have the first 8 place values in binary, and then I'll convert to decimal, and that gives me 128 plus 16 plus 8 plus 4 plus 2 plus 1, or 159 in decimal. There are often several ways to approach converting between number systems. You should use the one that works best for you.
So I recommend practice. That's ultimately, you're going to find a way, whatever the way that is, just practice it over and over again. Go between the different numbers. What you don't want to do is use a calculator because Windows comes with a calculator. You can just open up your Windows and operating system, and here, oops, that's calendar, not calculator. You can open up your programmer, and here's all your conversions. So you could say, what is in hex? What is AD78 in binary, right? Here it is right here, 1011, right? So don't do that, because going into your CCNA exam, if you continue into networking, going into your A+ exam, if they're going to ask you something simple like converting between the two, it would be helpful for you to actually know how to do it. If you practice on a calculator, that's not going to help you. Again, decimal to hex, convert the steps, convert the decimal number to an 8-bit binary, divide it in half, convert each half into its equivalent hex digit. For example, 168 and in binary is 10, 10, 1000. Two groups divided into 10, 10 and 1000. 10, 10 is A and 1000 is 8. It's really not that hard to do. Go in the other direction, convert the hexadecimal number to a 4-bit binary string, create 8-bit binary groupings starting from the rightmost. So what they're saying there is if you have a long hexadecimal number, you still convert them to 8-bit binary, 4-bit binary strings, put them all together, and then divide those into 8 groups starting from the right. So D2 is 1110 and 0010. Squish them together, then convert that 8-bit grouping, each 8-bit group, 8-bit grouping to a binary number. All right, so that's enough for today. I did go over an hour. I apologize for that, but lots to learn. Hopefully, it didn't. You were able to grasp most of it. If not, it's a video. You can watch it again if you want. Most of this information comes from the A+ Guide to Hardware, Cheryl Smith's textbook, and it is geared to get you your A+ certification. I have confidence it will. That is the 220 1001 exam and 1002 exam. So if you're studying now, I'm here in the summer of 2022. If you're studying now for that certification, you need to get the certification before it changes to the next certification, which will be in 2023, the beginning of 2023. So sometime in 2023, it's converting to the next exam. So you need to make sure you take both the hardware and the software exam before that exam changes over so that you don't lose this information. Of course, you're going to just update the information with the new stuff, but if you're studying this, you definitely want to take this exam. My name's Don LaFon, Professor Don. I didn't have any students with me today because I had to remake this video. So if you're watching this as a recording inside of our Canvas classroom, please ask questions in the help discussion forum. I'll be happy to answer them. If you're watching this on YouTube, thank you for watching my video. I appreciate it. Please thumbs up and follow me. You can hit the notification bell to get updates when I release more videos. There's probably another 10 videos coming out this summer from this book, this A+ certification book. So you'll get a notification when I release the next video, and I hope they're helpful for you to earn your A+ certification. Please, when you earn your certification, come back and drop a comment or send me a message and say that you earned your certification so we can all clap you on the back. I don't know, say thumbs up. I don't know. We'd like to hear it. I'd like to hear it. So anyways, good luck in your journey, and I hope you have a great day. Thank you for watching my video. Let me stop sharing. I guess that would have been helpful. You could have seen me talking to you. I don't know if that's better or worse. But again, Don LaFon, Professor Don, and it's been my pleasure to teach you about a little bit about software and a little bit about cloud infrastructure, virtualization, and internet connectivity, and then we finished with binary, decimal, and hex, and converting between the two. All right, thank you so much, and I'll see you again in a week.